Okay, let's give you guys some more practice. So this is a distance time graph for a given object. So you could imagine this as to be like you and your dad sitting in a car, and this is a distance time graph representing the distance traveled by the car. Okay, so well anyway, given this distance time graph, work out or tell me when the object is stationary. So, for example, I could say from here to here, the object is stationary just by looking at this, or from here to here. So you could say the object is stationary between uh, between t equals 17 and t equals 18. So between here and here, the object or the car, if you like, is stationary. So anyway, given this distance time graph, um, tell me or write down when the object is stationary. So remember, when you're given a graph, try and visualize the three graphs inside your mind: acceleration time graph, and then you've got your speed time graph, and then you've got your distance time graph, and try and identify which one we're talking about. Here we are talking about this graph. Okay, well, do whatever you have to do. Looking at this distance time graph, tell me when the object is stationary. So press pause and have a go. Okay, so the object is stationary between t equals 3 and t equals 5, and here the object is stationary when when t equals 10. So what that means is when an object is stationary, it's sort of like its speed being zero. You see, you're given this distance time graph. Let's say something like this. Okay. Well, hang on, let me do it again. So let's just say something like this. Now, uh, the this is a distance time graph, so the gradient of this represents the speed. You see, when it's horizontal when it's horizontal like this, the gradient is zero. So which means the well you're at the distance time graph. The gradient represents the speed. Remember the speed time graph. The gradient represents the acceleration. Well, here you're given the distance time graph, so the gradient represents the speed. When I ask you when is the object stationary, it means another way of looking at it is when is the speed zero? Well, the speed is zero here, 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 and here because the gradient is zero. Okay. Well, anyway, so given this very same graph, tell me when the car is moving the fastest. So imagine you and your dad sitting in a car here. Okay, time equals zero, so you start here. Now, so this here is the actual distance. Okay, 16 meters away from the start. So this line here represents distance. Distance. So well, translating this distance time graph into this into here, well, it would be like this. After 3 seconds, the car would have done 2 meters. So after 3 seconds, the car would have done would have traveled 2 meters after 3 seconds. Okay, and then it's stationary for 2 seconds here. So it's stationary 1, 2, and then it starts moving again. So then it will get to 6. Then it would get to 3 meters. When it, well, it's stationary. So hang on, sorry. Let me start again. So you are here after hang on. So you are here at the moment. After 3 seconds, the car would have done 2 meters. So after 3 seconds, it would have done 2 meters, and then it's stationary for 2 seconds. So 1, 2, and then it would have done well. It would have been it would get to 3 meters away from the start after 6 seconds. So well, another second later, it would be 3 meters away. So it would be here. Okay, and then it's stationary 1, 2, 3, 4 seconds. So stationary 1, 2, 3, 4 seconds, and then it would travel really fast. Well, 1, 2, 3, 3 seconds later, it would be 9 meters away. So 3 seconds later, it would be 9 meters away. So this here is 3 seconds. Okay, and then it would stay at 9 meters for 1, 2 seconds. So 1, 2 seconds, and then it would go backwards now, because look at this here. It was at 9 meters away from the start. Here it's now 6 meters away from the start. So what that means is, if you're in a car, you drove all the way up here, and then 2 seconds later, you would have gone back to 6. So that means you and your dad sitting in the car would basically be reversing back. But well, don't forget, when you're reversing, there's still a speed, so the car is still moving from here to here. Okay, so what this means here, because it's a negative gradient, it means, well, there's going to be a negative gradient here. It means a negative, well, the speed is going to go in this direction. Okay, it would be a negative speed, but that doesn't really make sense. A negative speed. You could say this. Well, there's still a speed, but it's going backwards. You could say the velocity is minus the gradient of this thing here. But don't worry about this velocity. Just know that there is still a speed here, but it's going back in this direction. Don't worry about the velocity. I'll explain another time. But you could say the velocity is negative, but you can't say the speed, a negative speed. Well, it's going in this direction. Well, anyway, let's go back in time here. So here, given this distance time graph, tell me when the car is moving the fastest. Okay, remember, if you're here and you're going backwards, the car is still moving, so it still counts as a speed. Okay, there's still a speed in that car. Well, anyway, do what you have to do. Press pause and have a go. So here, so visualize the three graphs: acceleration, time, speed, time, and distance, time. By me giving you this graph, we are talking about distance, time. So inside your mind, you should be visualizing the third graph down. Okay, so you're here now. The gradient of this graph represents the speed. Okay, so the gradient of this here represents the speed of the car between time equals 0 and time equals 3. Okay, so the gradient here is 2 divided by 3. So 2 divided by 3. The gradient here is 1 divided by 1. So that's 1. Okay, so the speed here is 1. 1 meters per second. The speed here is less than 1, because 3 over 3 is 1, but this here is less than 1. The speed here would be, 2, 4, 6 divided by 1, 2, 3 divided by 3. So the speed here is 2 meters per second. Okay, the speed here, well, it is a negative gradient, but you can't really say a negative speed. You could say well, anyway, let's do this. 1, 2, 3. So the height is 3. The across here is 2. So the gradient is negative 3 over 2. But you can't really say the speed is negative. Blah 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 blah. You can say the velocity is like speed, but you're allowed to talk about the direction. So here you can say the velocity is negative 3 over 2 meters per second. But you can't say, oh, the speed is, well, you can't use negative when you're talking about speed. You can just say, oh, the speed is 3/2. Okay, let's forget about velocity for the time being. I will explain that another time. But when you use velocity, you're allowed to use negative. It just tells people which direction you're going in. But because we're going to forget about velocity for the time being, we're just going to talk about speed. Now, speed here, we can't use negative speed, so we just say the speed is 3/2. But just remember, we are going backwards. So even though we have a speed of 3/2, the speed is going backwards. Okay, just remember, the speed is going backwards. You see, it's really confusing when you talk about speed here going backwards, and you could just say, oh, velocity is negative 3/2 meters per second. So it's like speed, but you're taking direction into account. But let's forget about velocity for the time being. The question is saying when is the question is asking when is the car moving fastest? Here it's moving less than 1. Here it's 1. Here is 2. Here is 1 point something. 1.5. So the car is moving the fastest between t equals 10 and t equals 13. Okay, so at this point here, the car is doing 2 meters per second here, and the car is also doing 2 meters per second here. Okay,